عليكم السلام.
No problem. Let me start. Have a seat, please. Actually, you know me. I'm Dr. Ranj Baron, Associate Professor of Physiology. Actually, I start kidney physiology with kidney functions. The first function of the kidneys actually is acting as an excretory organ. Why do we say they are excretory organ? Because the main function is urine formation. Actually, waste materials, excess water, excess electrolytes actually are excreted by the kidneys. Okay? The second one is the kidneys are regulatory organ. What does it mean? Actually, when the kidneys regulate, actually excrete excess water, excess electrolyte, it means it is a regulatory organ. Got it? And let me put it simple. Let me put it in a simple way. To put it in a simple way, we have to say we have actually long-term regulation. Long-term regulation is actually excreting excess water, electrolytes, waste material, and so on. Okay, and by this one, in the long term, the kidneys control blood pressure. That is because they determine the blood volume. Was it clear? Okay. And we have short-term regulation. This is what? Some vasoactive substances. S stands for substances here. Such as, for example, renin. Okay, we will talk about the role of renin. Got it? In renal physiology. Actually, by separating vasoactive substances, the kidneys are able to control blood pressure in short term. Got it? By excreting waste material, they control blood pressure in long term. By separating vasoactive substances, kidneys control blood pressure in short term. No question. The kidneys are considered to be endocrine glands. It means they are able to secrete hormones. Which hormones? First is
طلاب بالاخير تقدموا شوي لقدام.
Dear Toddler, dear Banat, please be energetic, okay? Actually, your energy has a significant effect on me. in order to teach better. Please be honest. Don't touch this. Don't laugh so good. Okay, thank you. Don't talk, please. Kidneys are considered to be endocrine glands. It means they are able to secrete hormones. Which hormones? The first one is renin. We will talk about renin role in renal physiology. The second one is erythropoietin. Actually, you know what erythropoietin is. Erythropoietin is secreted by
the kidney.
the kidneys 90% and liver 10%. Remaining 10% is secreted by liver. Actually, we have studied in blood physiology. 1,25 hydroxycholic acid. It is active form of vitamin D3. Okay, you will study in endocrine physiology regarding vitamin D3 and kidneys. Regarding kidneys, we will talk in renal physiology. Renin and kidney. We are going to talk about renin and kidney in the next sessions. Buddy, no question? What's it here? Actually, today we are going to talk about the morphology of a typical nephron, mechanism of urine formation, and glomerular filtration rate. Glomerular filtration rate actually is the same as GFR. Actually, GFR stands for glomerular filtration rate. Okay? Regarding the kidneys, two kidneys lie on the posterior wall of the abdomen, outside the peritoneal cavity. Okay, regarding the weight, it weighs 150 grams. And regarding the size, is in the size of clenched fist. Okay, for example, my kidney is in this size. Okay, two kidneys, two ureters. Bladder and urethra form actually urinary system. What's their function? Actually, we know the urine is formed by the kidneys. Okay, and urine composition doesn't change in the other parts of urinary system. What's the function of ureters? Actually, just they carry urine from the kidneys toward bladder. What's the function of urine bladder? Yes, a storage of urine. Just actually it stores urine until it is empty. Buddy, regarding the kidneys, if you see the kidneys, the medial side of the kidney has an indent region. This region is called hilum. Okay, be careful please. Any component which enters the kidney and any component which leaves the kidney is through hilum. Passes through hilum. Which items passes through hilum? What do you think? Renal artery. Renal artery.
Renal vein.
Renal vein.
The ureters.
Ureters. Very good. Lymphatics and nerve supply. Okay, these 5 components pass through hilum. Got it?
Yes.
Very good. When we bisect the kidney from top to bottom, okay, when we bisect the kidneys from top to bottom, we are able to see 2 different areas. Outer area is called, outer region is called the cortex. Inner region is called medulla. Okay. مرسی دکتر جان. خیلی متشکرم. Outer region is called cortex. Inner region is medulla. Okay. As you can see in an adult person, okay, There are 8 to 10 conical shaped masses. These conical shaped masses are called renal pyramids. Okay, as you can see here, the base of each pyramid originates from the border between cortex and medulla. I mean here, the base of each pyramid. At the tip of each pyramid here terminates in papilla. Okay, papilla actually is here. The urine actually flows here toward papilla, and then after that it enters minor collex, major collex, and after that it enters renal collex. What is worth mentioning is that after leaving the tip of pyramid, there is no change in composition of urine. Got it? I mean, there is no change in composition of urine in, for example, pelvis, renal pelvis. Got it? There. Don't you have any question? Actually, I'm going to talk about renal blood supply. 22% of cardiac output reaches the kidneys. One kidney or two kidneys? What do you think? Two, what do you think? Dear Galant. Is it 22% of cardiac output reaches the kidney or kidneys? One kidney. Don't forget. Any value, any number we will talk about in renal physiology is for two kidneys. Any number, any value. Got it? It is for two kidneys. It means in each minute, 1100 milliliter of blood reaches two kidneys. Actually, this amount of blood is much more than metabolic needs of the kidney. Okay? For the sake, it is as a result of kidney function. Okay? Because the main function of the kidney is formation of urine in order to get the body rid of waste materials, excess water, excess electrolytes, and so on. Got me? No question? Okay, renal circulation is unique because of two main reasons. One is amount of blood flow. Blood reaches two kidneys, as I told you, it is very high, much more than metabolic need, as I told you. Got it? The second one is we have two capillary beds in series. Actually, in normal circulation, we have arteries, arterioles, capillaries, venules, and veins. Alright, but here we have two capillary beds in series. Okay, let me show you. Actually, renal artery comes inside the kidney through hilum. Okay. And it forms interlobar artery. A stands for artery. Interlobar artery forms some arteries which are called interlobular artery. After arteriole, okay? And then we have glomerular capillary. C stands for capillary, okay? After that, we have efferent arteriole and peritubular capillary. Here you can see two capillary beds in series. What's the importance of efferent arteriole between two capillary beds? Actually, one of the differences between actually blood pressure in afferent arteriole and other parts of other organs is that mean blood pressure in our capillaries in other organs is 17 millimeter of mercury. But pressure here is 60 millimeter of mercury. With this pressure, actually blood flows inside the glomerular capillaries. Right? Actually, this pressure is in favor of filtration because pressure is high. Filtration by which transport mechanism? What do you think? Simple diffusion, osmosis, facilitated diffusion, primary active transport, secondary, which one?
Simple.
Simple plus osmosis, okay? Osmosis is simple diffusion of water. Okay. As a result of this high blood pressure, we have filtration here. Filtration by simple diffusion. But it means there is no neutral energy as ATP. Was it clear? Was it clear?
Yes.
No, okay. If you have any question, don't hesitate to ask. Okay. What's the role of efferent arterioles? Actually, efferent arteriole decreases blood pressure in peritubular capillary. In a way that blood pressure in peritubular capillary reaches 13 millimeter of mercury. This is the main function of efferent arteriole. Efferent arteriole decreases blood pressure in peritubular capillary. For what? Actually, this low pressure is suitable for reabsorption. But low pressure allows substances to come inside the capillaries. Got it? It is suitable for reabsorption. And who decreases blood pressure in peritubular capillary? Efferent arteriole. Got it? Reabsorption by which mechanism? Here you can see simple diffusion by different mechanism. Simple diffusion, osmosis, primary active transport, secondary active transport, facilitated diffusion, got it, or transport. Mechanisms are involved here. Okay. After peritubular capillary, actually we have arcuate vein. Arcuate vein. And after that, interlobular vein. Interlobar vein. Renal vein. As you know, renal vein leaves the kidney through hymen. Got it?
Yes.
Very good. You want to take a picture?